Hey everybody, this is the video for April 22nd, whether you're my class or Mr. Clendenin's. We're sharing videos and everything like that. So hopefully you guys have a little bit of an understanding on geometric sequences. We're gonna kind of expand on that today and see if we can understand it a little bit more. All right, you guys, so what you should have learned yesterday was the rule for geometric sequences. It is a sub n equals a sub 1 times r to the n minus 1. Now when you plug in a value for a sub 1 and r, make sure that you never multiply them together because the r has an exponent and then exponent rules won't allow us to multiply those bases. So here is number 1. We're going to have a sequence of 4, 10, 25, 62.5, comma, dot, dot, dot. And what we're going to do is we're going to find the 35th term. So we're going to find the 35th term. Okay, so why is a rule important? Because what I don't want to do is find all of the numbers in the sequence until I get to the 35th spot. That's a waste of my time. So I want to be able to write a rule for this. Now, we only know arithmetic from last week and geometric. After that, rules can become a little bit challenging to write. So what I'm going to do is see if it is arithmetic first. Add 6, add 15. Since it's not add or subtract the same number each time, it's not arithmetic. Next, I check for geometric. Now, Mr. Clendenin should have showed you how to find that common ratio. If you take this number divided by the number in front of it, this number divided by the number in front of it, so on and so forth, you get a common ratio. So this is geometric, where you are multiplying by 2.5 each time. And the rule of thumb is if you have decimals in your sequence, use decimals. If you have fractions, use fractions. So in this one, I should use decimals because of the 62.5. So now that I have that, I can easily write my rule. It is a sub n is equal to a sub 1, which is 4, times r 2.5 to the n minus 1 power. And that's my rule I will use. But now to find the 35th term, I'm going to do a sub 35 is equal to, and I'll plug 35 into n. I got 4 times 2.5 to the 35 minus 1 is 34th power. So 4 times 2.5 to the 34th power. You go ahead and you put that in your calculator. I would do the exponent part first, 2.5 to the 34th, press enter, and then multiply by 4. And I got the 35th power is scientific notation of 1.36 times 10 to the 14th power. Now on your homework for a problem like this, I actually wrote it out what it truly is too. So please remember scientific notation would mean that you take the 1.36 approximately, and I did round that in my calculator, but I moved the decimal 14 spaces to the right. So it's 1, 2, 3, comma, 4, 5, 6, comma, 7, 8, 9, comma, 10, 11, 12, comma, 13, 14, oops, I made a mistake. The comma shouldn't go there. I've seen a lot of kids in the past think that, oh, if I move it 3 spaces, it's a comma. You got to kind of wait till you're done and put your commas. So the commas were off all one spot. Hopefully you caught that before. But I would have 136, comma 0, 0, 0, comma 0, 0, 0, comma 0, 0, 0, comma 0, 0, 0, approximately as my 35th term. So when you're doing scientific notation, yes, every 3 spaces is a comma to help us separate our place values, but wait until you're done and work back from where the decimal is, not from where you moved the decimal. I've just seen way too many kids put commas right away. So hopefully, again, you caught that was going to be a mistake before we actually got all the way to the end. Okay, let's move on to number 2. We have 3 examples today. Number 2, very similar problem, except we're not going to be able to use decimals, and we'll see why. So for number 2, we have negative eighths, 16 thirds, negative 32 ninths, 64 27ths, comma, dot, dot, dot. And we're going to find the 8th term. Okay, now I know the 8th term is not that far. Since we already have 4, we could find the 5th, 6th, 7th, 8th pretty quick. But what if it was find the 108th term? We want to learn how to use the rule appropriately. So I realize it's not arithmetic. It is not add or subtract the same number. But it's probably geometric then. So if I took this number divided by this number divided by this number divided by this, in decimal format, I get negative 0.6 repeating. We should know that's negative 2/3. But again, you could show the work as 16/3 divided by 8 is multiplied by as reciprocal, which is, it's negative 8, sorry. 16/3 times negative 1/8. These cross reduce to make a 2. So there's still a negative sign there, negative 2/3. That's why I'm getting that. Or again, I could do negative 32/9 divided by the previous term. Division, you have to multiply by the reciprocal, so it's negative 32/9 times 3/16. And let's see what cross reducing happens. The 3 and the 9 make 1/3. The 32 and the 16 make 2/1. So I have negative 2 on top, positive 3 on bottom. I get a common ratio. So a lot of times you should be doing that scratch work off to the side. All right, so we know it's geometric and we know the common ratio is negative 2/3. So writing the rule is very easy. There's no simplification or anything. It's a sub n equals the first term, negative 8, times the common ratio, negative 2/3, to the n minus 1. And you never get to multiply those together. Please don't make it positive 6. I know negative 8 times 2/3. Oh, next not positive 6 anyways. Never mind. So it would be 16/3. We don't want that though. So this is our rule. And to find the 8th term, you plug in 8. So a sub 8 is equal to negative 8 times negative 2/3 to the 8 minus 1 is 7. But now when we type that in a calculator, we get a decimal answer. And what we just stated was we want everything to be in fraction format. So I don't want the decimal equivalent. I want the exact fraction. So how do we do that? Well, we know how to power a fraction. The power goes to the numerator and the denominator, but the negative sign only goes with one of them. So I always take the negative with the numerator. So now I really have negative 8/1 times negative 2 to the power of 7 over 3 to the power of 7. And I would look if anything is going to reduce. Now what I mean by that is, since we know there's a bunch of 2's there, a bunch of 3's there, think about if 8 has any number that could reduce with the denominators, and there isn't. So I can simply type all of that in my calculator. If I do negative 2 to the 7th power, it's a negative big number, times negative 8 is going to be a positive 1,024. And on bottom, I don't really got to worry about the 1, but 3 to the 7th is 2,187. And that is the value that we are looking for. So again, if you type that in your calculator, you're going to get the decimal approximation of that, but we want the exact value in fraction form. All right, last example. It's a very similar problem to number 2, except something might reduce. All right, so here is number 3. We have 20, then 10, then 5, then 5 halves, dot, dot, dot. And we're going to find the 11th term. Okay, so again, is it arithmetic? No. Minus 10, then minus 5. If you're not adding or subtracting the same number each time, it's not arithmetic. So it's got to be geometric. 10 divided by 20 is 1/2. 5 divided by 10 is 1/2. 5 halves divided by 5 is 1/2. So the common ratio is 1/2. So I have a sub n is equal to a sub 1, 20, times the common ratio 1/2 to the n minus 1 power. If I want to find the 11th term, I have to plug 11 into n. This becomes a sub 11 equals 20 times 1/2 to the 11 minus 1 is 10. Same concept. Since I have fractions in the original problem, I shouldn't use decimals. If you type that in a calculator, you're going to get a really ugly decimal. That won't turn back into a fraction. So we need to know how to simplify it correctly. I have 20 over 1 times, well, 1 to the 10th power is still 1, and 2 to the 10th power is 2 to the 10th. And I really look at the a sub 1 and the denominator to see if anything is going to reduce. And hopefully you know that if you broke 20 down into prime numbers, it's 2 times 5, and some of those 2's are going to wash away with those 2's down there. So now I have a sub 11 equals, the top is 2 times 5 times 1, and then it's 1 times 2 to the 10th, and there are 10 2's down there, but I don't want to write them all out. So I just think about this. What is going to happen with these 2 on top, these 2 2's on top, and there's 10 2's on bottom? Well, 2 of them are going to cancel. So you can reduce that, and that 10 will say that there's only 8 of them now, and your 11th term in fraction format is 5 over 2 to the 8th power is 256. So please make sure you know how to get the fraction answer as opposed to the decimal answer that your calculator is going to get if you simply type it in. All right, hopefully geometric sequences are going okay for you. Setting up the equations actually a lot easier. There's no simplifying or anything like that. But then in order to do this math, it can be a little bit more difficult. Reach out to me or Mr. Clendenin on Google Chat, Google Hangouts, emails, whatever, just in the classroom thread. Anything you guys need for us to help you, just let us know. All right, you guys, it's your boy, Mr. P. Here are your 2 homework problems, and there's only 2. There they are, if I can zoom in. That's 12 in the very first problem. Sorry, my handwriting got a little sloppy and I erased. All right, you guys, good luck.